Imagine this. You're deep beneath the ocean, sealed inside a steel tube the length of a football field. Then something goes wrong. A fire, a flood, a sudden loss of power. The lights flicker. Oxygen begins to vanish. And hundreds of meters above you, the surface feels like another world entirely. In that moment, survival is measured not in days, but in hours. For decades, submariners have lived with this nightmare, trapped under crushing pressure with no way out, but engineers refuse to surrender. From the tragedies of history came extraordinary escape and rescue systems, built to snatch life from the jaws of the deep. Tonight, you'll discover how they work, and whether you would trust them with your life. Submarines are unforgiving machines. When they fail, they rarely give second chances. In 1963, the USS Thresher was lost off the coast of Massachusetts. A catastrophic systems failure dragged her below crush depth. 129 men were never seen again. There were no survivors, no escape, only silence. Decades later, in August 2000, the Russian submarine Kursk sank after a torpedo explosion. Trapped sailors pounded on the steel walls, sending desperate signals. For days, the world listened. But rescue came too late. All 118 men perished, many suffocated in darkness, just meters from salvation. These tragedies revealed the cruel reality. Once a submarine is disabled, the ocean becomes a tomb. But from these horrors came change. Engineers and navies across the globe vowed never again to leave crews without a fighting chance. Out of disaster was born the race to engineer systems of survival beneath the waves. The earliest solutions were simple, but brutal. Submarines were fitted with escape hatches, tiny chambers known as trunks. Inside, sailors donned bulky suits, inflated with air, then shot upward like human torpedoes. These SEIE suits could, in theory, bring a man hundreds of feet to the surface. But the risks were terrifying. Ascent too fast, and the body is torn apart by decompression, sickness, the bends. Rise too slow, and cold waters claim your strength before you break through. For decades, escape suits and hatches saved some lives, but they were never enough. Submarines carried dozens, sometimes hundreds of sailors. One by one, in darkness and chaos, few could survive. That led engineers to ask, what if, instead of escaping alone, the crew could be rescued together, safely carried to the surface by machines built for that one mission? The answer came in the form of rescue capsules, miniature submarines designed for one purpose: docking onto a stranded sub. The U.S. Navy's DSRV, or Deep Submergence Rescue Vehicle, looked like a steel bullet. It could dive thousands of feet, guided by sonar and desperation, and clamp itself onto the hatch of a crippled submarine. Inside, terrified sailors would crawl upward into the capsule before being carried to safety. Britain built the LR-5. Russia designed its own variant, small lifeboats in the abyss. But the challenge was immense. Rescue capsules must find a target in total darkness, under crushing pressure, with storms raging on the surface above. And even then, the process of docking onto a tilted, damaged submarine demanded precision beyond belief. For the sailors inside, hope arrived in the form of a faint metallic clang as the capsule locked onto their hatch. That sound meant one thing: life had found them.
Just a little further.
But reaching the surface was not the end of danger. The human body is fragile against the physics of pressure. When submariners ascend too quickly, nitrogen bubbles can form in their blood, causing decompression sickness, crippling, even deadly. To combat this, engineers turned to an ancient invention, reborn for submarines, the diving bell. Lowered like an elevator of air, these bells could connect to hatches, load multiple sailors at once, and rise slowly toward safety. Once on the surface, crews were transferred directly into pressurized chambers, giant steel rooms where pressure could be released gradually, hour by painful hour. Here, survival meant waiting, breathing carefully controlled air, as doctors monitored every heartbeat. In these chambers, men who had faced certain death beneath the ocean were reborn, step by step, into the world above. Escaping the ocean was only half the battle. Living through it required science and patience. No rescue can succeed without help above. On the surface, specialized ships stand ready, floating hospitals armed with cranes, sonar, and life support systems. These ships deploy rescue capsules, lower diving bells, and coordinate international fleets during crises. But their mission doesn't end when sailors break the surface. Survivors are rushed into hyperbaric chambers, sealed rooms of thick steel where pressure is carefully reduced, preventing their lungs from collapsing and their blood from boiling. Inside, doctors work tirelessly, fighting hypothermia, shock, and the scars of the deep. It is here, not in the ocean, where survival is finally secured. And yet, every rescue carries its own danger. Storms can rage, equipment can fail, and minutes can mean the difference between life and death. To save submariners, engineering above the waves must be as precise, as tireless, as the systems that dive beneath them. Today, submarine rescue has entered a new age. Robotics and unmanned drones now scan the seabed, mapping disaster zones where no human diver can survive. Rescue capsules are smarter, faster, more agile, capable of docking with submarines at angles once thought impossible. Some submarines are now designed with detachable escape pods, lifeboats that separate entirely from the vessel, carrying the crew upward in one desperate shot at survival. Around the world, navies that once faced each other as enemies now cooperate in rescue. NATO's International Submarine Escape and Rescue Liaison Office brings together fleets from dozens of nations, ready to deploy across the globe. Because when a submarine is trapped, politics fall away. What remains is the fight for human lives. And still, despite every advancement, the ocean never forgives. Pressure, darkness, and distance remain merciless. Technology buys time, but only time. The question lingers. In the next disaster, will these machines be enough?
We have multiple contacts in the sector.
Confirming new coordinates for immediate dispatch.
In the end, submarine escape and rescue is not just engineering. It is defiance. Defiance against the crushing weight of the sea, against the silence of darkness, against the certainty of death. Every capsule, every chamber, every rescue ship is a promise that no sailor will be abandoned to the abyss, but the ocean remains undefeated. Each new system is a fragile bridge between life and loss, built by human hands in a world beyond human reach. The next time disaster strikes, submariners will depend on these machines and on the people who built them. Would you trust them? If you were trapped hundreds of meters down, With oxygen fading, would you place your life in their hands? The answer to that question may one day decide your fate. And as we move forward, another frontier waits the nuclear submarines that patrol silently in the dark, carrying the fire of nations beneath the waves.
That we are all together.
That is our next story.